So, asymptotes to algebraic curves. Okay, what is asymptote? Suppose this curve, red color. Better I will change the color so that. Okay, let it be red itself because there I have drawn. So you have this curve, right? This curve. Okay. So and this is a straight line. This is a straight line. This is y-axis and this x-axis. Okay. So now if I enlarge this portion alone here, you look here from this. I take any point on the curve like this, infinite number of points. I am taking so many points. Okay. So from this I am dropping perpendicular to this line. So what do you find? As y increases towards infinity, p tends to 0, right? P tends to 0. Infinity means that is there is no definite number, right? Definite number is not there. So it will be somewhere, it will never meet the curve, but it will become very close to the curve. This line will become very close to the curve. That's why this line is called, this line will become very close to the curve, and this curve, this line is called asymptote. This line is called asymptote to the curve. Okay, this line is called asymptote to the curve. Fine. So asymptote is nothing but it is a straight line which meets the curve at infinity, but it doesn't meet, means it will be very closer to, means it will tend to 0. Okay, it will tend to 0, it will never meet. So that is what the asymptote is. Suppose there is the algebraic equation, the curve is f of x comma y is equal to 0. Okay, so somehow if I can make this curve in this format, x minus a y raised to the power n plus a1 y raised to the power n minus of 1. Okay. Plus a0 y raised to, sorry, a2 y raised to power n minus of 2 plus dot 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 a n minus of 1 y 1 plus a n is equal to 0. Okay, if I can form this given curve, this is the given curve, given curve is this, and I am rearranging the terms and making in this format, right? Now if I divide by x minus of y, and if I divide by yn, what we get, will be getting plus of y, so it will be 1 by y, right? This will be 1 by y, so I can write it as y plus a2 by y2 y square. So somewhat like this we will be getting, right? Now when y tends to 0, y tends to infinity, no, actually we are tending towards infinity. Okay, when y tends to infinity, what happens? X minus of a is equal to 0, right? Because all terms will become 0 here. So this will, all this term will become 0. So this will be the equation of this asymptotes. Okay, this will be the equation of this asymptote. So that is x is equal to a, which is parallel to y-axis. This is parallel to y-axis, right? Similarly, we can find out for parallel to x-axis also. Okay, this is what the asymptote physical significance is. Okay, so next I'll discuss for means if I take the curve like this, this is the asymptotes, and you have the curve like this, right? Then for this, if I follow the same procedure, I will be getting y is equal to, which will be parallel to x-axis. But it is not always true that there will be the asymptote parallel to x-axis or parallel to y-axis. There may be the asymptotes which is parallel, which is neither parallel to x-axis nor parallel to y-axis. It will be oblique. Okay, or sometimes that asymptote may not exist. That also is possible. Okay, so we will see the little bit derivation of this asymptote, how to find out that. Okay, yeah, fine. We'll do it in the next class. Thank you.